All right, class, so today I'm going to cover the difference between a sampling distribution versus a distribution of sample means. This is a lot of what we covered in quiz 6.5, and I got quite a few questions, so I thought I'd go ahead and make a little video in order to clear a few things up. So let's talk about puppies. So let's assume that 6-week golden retriever puppies' weights are normally distributed with a mean of 8 pounds, that's our mu, and a standard deviation of 1.2 pounds, that's represented by sigma, okay? So if we were to sketch a normal distribution of this graph, our x-axis is going to be the weights of puppies, and our y-axis is going to be the frequency at which those rates occur. Now, I know my mean is going to occur the most because it's a normal distribution, right? So here we have 8 as our normal distribution, and that's where our peak is going to be. Okay. So my standard deviation is 1.2 pounds. Let's go ahead and sketch this out. If I go plus 1 standard deviation, I'm at 9.2. If I go plus 2 standard deviations, I'm at 10.4. And if I go plus 3 standard deviations, that puts me at 11.6. Now I have to go standard deviations in the other way, right? Because there could be puppies with means with weights less than 8 pounds. So if I go 1 standard deviation away, that puts me at 6.8. If I go 2 standard deviations, that puts me at 5.6. And if I go 3 standard deviations away, that puts me at 4.4. So here I have our weights of our puppies and how frequently they occur. So now I'd like to know, if one puppy is randomly selected, what is the probability that the puppy weighs less than 8 pounds? So we have to remember that our mean is 8, our standard deviation is 1.2, and we have a normal distribution with 8 as our mean, and I want to know what is the probability that a puppy weighs less than 5 pounds. So I'm trying to find the area over here in this tail. And I'm going to do that by figuring out how many standard deviations 5 is away from 8, and that's going to give us our z-score. So my z-score in this case is going to be our data value, which is 5, minus our mean, which is 8, over our standard deviation, which is 1.2. This gives me negative 2.5, okay? So then I go to my z-table, and I'm going to go to the negative side. I'm going to go to negative 2.5, and I will find a z-table value of 0.0062. So that's the area in this tail over here is 0.0062. Now I need to convert this to a percentage in order for the probability, okay? So that's a probability of 0.62%. I want to talk about the central limit theorem real quick. So the central limit theorem states that if one were to look at the distribution of sample means, okay, so I'm not looking at the weights of individual puppies, now I'm looking at the weights of groups of puppies, right? The means would be the mean of the population, and the standard deviation would shrink because we're dividing it by the size of the population. So as our sample size increases, our deviation decreases and our graph gets tighter. So let's take a look. In red over here, I have a graph of sample size 100. It's pretty spread out. If I were to take sample sizes of 1,000, my graph gets tighter. I still have the same mean, as you can see, but my values are less spread out, so I'm going to have a smaller standard deviation, okay? And the means of all the sample means approach the true population mean, mu. So let's say 25 puppies are randomly selected, okay? I'm looking at the graph of the distribution of sample sizes of 25 puppies, and I'm graphing all of their means. I'm still looking at when means equal 8. I'm still looking at the probability that these 25 puppies, if I added all their weights together, would have a mean weight of 5 pounds. Okay? So I'm going to calculate this using our new standard deviation, which is sigma over the square root of n. So I have to find a z-score, right? I still want to find this area over here. And what we know is as we take samples that are bigger and bigger, our sample gets tighter, our standard deviation gets smaller, so the probability is going to decrease. Now, I have z equals my data value minus our mean over our standard deviation over the square root of n, because we're looking at the distribution of sample means. The word means tells us we have to use this different standard deviation. So that gives me 5 minus 8 over 1.2 over the square root of n, which gives me negative 3 over 0.24, which is negative 12.5. Now, we know that most of our data within 3 standard deviations is 99.7% of data, right? My z table doesn't even go to negative 12.5, right? So the probability of me picking 25 puppies and those puppies having a mean less than or equal to 5 pounds is practically 0. So you can write 0. I believe we use the 0 plus notation, meaning a number really, really, really close to 0. So for our last question on this quiz was true or false. And it said, regardless of the sample size of a sample of puppies taken from a population of 6-week-old golden retriever puppies, because that was our population we were looking at, the probability that the mean weight of a sample is 9 or more pounds would be much smaller than the probability that the mean of a single puppy would weigh more than 9 pounds. That's true. Let's take a look at this real quick. So here I have one puppy, and here I have a sample of puppies. Both have a mean of 8, and I want to know the probability that a single puppy would weigh more than 9 pounds. So I'm trying to find the area over here, and I want to know the probability that a sample of puppies would have a probability over 9 pounds. Okay, so let's pick a sample size because it isn't given one to us. Why don't we go ahead and pick a sample size of 25 again? Okay. So I'm going to calculate this area over here. I'm going to calculate this area over here. So first I'm going to calculate the z-score for over here. Let's change colors. Let's do this in orange. So I have z equals my data value of 9 minus our mean of 8 over our standard deviation, which is 1.2. Again, we saw that on the first slide. That gives me a value of 0.83. So 9 is 0.83 standard deviations away from the mean. So I go to my z table and I find a value of 0.7967. Now here's the thing. Z tables tell us the value less than 9, right? So the area over here is 0.7967. So if I want to find the probability that a single puppy would weigh more than 9 pounds, right? That's going to be 1 minus 0.7967, which gives me 0.20, just about. So that means my area over here is 0.20. So the probability that of picking a single puppy that weighs more than 9 pounds is 20%. Now let's compare this to if I had a sample of 25 puppies. Okay, I still want to find the area over here. So I'm going to find my z-score. That's going to be 9 minus 8 over, we're looking at a distribution of sample means, right? We want the mean weight of the sample is 9 or more pounds. So I have 1.2 over the square root of 25. That's what I chose for my sample to be. We could have chosen any sample size greater than 1, right? Because the square root of 1 is 1, and then we would have gotten the same thing over here. That gives me 1 over 0.24, which is 4.17. So when I go to look this up in my Z table, there is not a number for 4.17. It stops at 3.99, okay? And that value gives me about 1, right? So that tells me the area to the left. So the area over to the left of this is almost 1, which means this area is almost 0. So the probability of a sample of puppies having a mean weight that's more than 9 pounds is 0.